midterm grading is delayed because some students took the makeup even last night. I didn't touch any at all by far. So I'm going to work on it this week. Hopefully next week your grade will be available. Part of another reason is that this time is mixture. Some students paper and pencil test, some students online test. Online means it's not really online, but electronic test. So partly electronic, partly traditional. So I need to collect them. Those who took paper and pencil test, if you are on site with me in class, then you may receive it from me directly. Those who are online may not. I do not know. But if anyone really wants to receive a copy of your testing, then I will scan it and send it to you. So that is possible upon request. But your grading will be edited on your Blackboard. All right. Question about your midterm exam? Is it clear, right? Okay. Today is yet another exciting topic that we are going to deal, process. So far, you guys had some experience in creating programs, right? So Java programs, Python programs. So we know the programs. And when we run the program on the computer, then we may have another name for your program. We sometimes call it a process, sometimes call it jobs. So I am going to give you a distinction of those. Well, many times you can use it interchangeably, but if you are showing yourself more technical, sensitive, and knowledgeable, then I want you to use the correct terminologies, right? Particularly when you have a job interview, then you need to use proper terms. So let me start with the process. Process is a running instance of a program. So you create a program. If you run that program on any operating systems, then we call that operating system, call it process. So it has a process ID. Process ID is assigned to any program which is running on operating systems. So I'm talking about the Linux operating systems. Windows is a little different. It's not really typical operating systems. So each process has a on this here. Oh, this is too small, right? So let's start with that. The process that we can see, there's a command called the PS, and then options, many other options, but we are talking about EF options. Before we do, well, we can run that. Then we see lots of processes running, right? Although I didn't put any program on it. Yes, I did some, right? VNC, I activated it. So my this Raspberry Pi OS that you can see coming from the VNC communications, right? So that is that. And some of the things that I under my name, for example, this is a bash. I have two shells, right? This is one terminal and another terminal. Each terminal has its own shell. Right now I have a shell here and there. Those who are running on Mac OS, if you want to run bash, you need to run it separately, not separately, explicitly. So by default, the operating systems running on your Mac OS, Mac Pro, that is G shell. There's another version of a shell. Steve Jobs, when he first invented his own operating, the Linux box in early 1990, he invented, he manufactured, in addition to Macintosh or Apple, he invented the Linux machine. We call that Next Linux machines. Probably none of you have heard of that. NEXT. Operating systems running on that machine is called Mach. Mach was another version of Linux, which was created at the Carnegie Mellon University. So Mach was the original basis of the Next, and it migrated further and further. Now that is on the Linux operating systems of your MacBook. So when you turn on the terminal, so each one has a Linux shell. Okay, so this is one Linux shell. The other one is the other Linux shells. Okay, so that is that. I'm going to run one simple program called the sleep. By the way, let's take a look at the manual of PS. There's a process status that we look at right now. Remember this is what this is a command that I used, right? PS. Option ENF, two options used. So on this, report to snapshot of the current processes. Then I have ENEF to see every process on the system using standard syntax PS-E, PX-EF, ELY, or AX to see every process on the system using BSD syntax. BSD stands for Berkeley Software Distributions. So AX or AUX. In this case, you don't need minus, but still okay, right? So those are the PS. Another one that I want to give you a demo is a sleep. Sleep is a delay for the specific amount of time. It's a good word, right? So we need it. I need it. The more, the better. The longer. How much did you sleep over the weekend? Not a lot. Me neither. Yeah. Saturday morning, I have another makeup test. Our students are so varied, so they are so dynamic, and some students do not take the exam. Those two uh, gracefully designated times, Mondays and Tuesday, right? Usually the one-time exam. That's what I have done when I was in many other previous institutions. But Mercy, okay. But still, there are some other students drifted away from that mainstream and asked. So we took Monday here, Manhattan campus. So I have been waiting here. No one came. Students who wants to come didn't show. But I was lucky. I was happy because I saw one student waiting outside. So I talked to him. We're taking my course. Yes, he was taking. And he came to me, and he was so kind. He was here. He came here on Saturday morning to let me know that he's going to take Saturday evening test. So I said, you don't need to come to let me know. But anyway, but he was on the evening test. That kind of things happened. So I came here Saturday early morning. Sunday, my wife wants to go to church. So I took her to the train station. Because of that, I woke up early. Came back home. I was not able to sleep because I have to prepare the course. Well, particularly this course. Yeah. Okay. So sleep. Sleep is another command. So let's demonstrate. If I want to do sleep, 100, I think this is 100 second, 100, and I hit. So it is running, right? It's still running, so I don't have any prompt yet until it finishes up. So when I check the process, this is a program, right? That program is running, so I check that process. Is there anything about sleep? I want to see it quick. Where is it? Before it stops. If you don't know, then we need to do here grab, right? Grab, slip. Oh, I have slip. Lucky. So the first one is that command, slip, right? That is a run by me, and this is process ID, PID 6107. And then later, this command, the command itself, PSEF, where there is a slip, right? That's what I did here, grab. So I have grab. So that is another process, 6112. So this kind of thing is the process, right? So one program slip, but I have two processes, right, for that slip programs, because I have two different command here.
Process ID, right?
Yeah, this is a process ID. So if you want to kill this process ID, then you can do kill 6107, then it'll be killed. If you want to kill really enforcefully, then it's already done. Therefore, this guy disappeared.
That's the process from since your Raspberry Pi been up, or that's all the process that has been ever ran.
In this case, all the process are running on the Raspberry Pi.
Okay.
Yeah, everything.
This current like power what?
Right.
Okay.
This current current time. Right. It's not. It's active.
Okay.
Actively running.
Numbers is great.
Let me show you because you asked that question. Let me bring up how process running. So toward the end of this, I think this is what process. This program is created, okay? And if I admit it in my computer and running, it's not yet running. I just loaded it on my computer. That is ready. It's a ready state of that process. So sleep is ready. And when I run it, then it is running. And then when it complete, then it terminates. This is normal procedure, right? This is normal procedure. While it is running, sometimes it may be interrupted. Okay, there's many kinds of interruptions available. Somebody that I want to try to do right now, I want to kill it, then there is interrupt, right? Another thing is some of the higher priority process comes in, then as you see that process on your Raspberry Pi, there are hundreds processes running if it is so busy. Some process is higher priority, some process is low priority. So we'll look at that also. So if my program is normal priority, but if some other high priority process comes in on the ready states, then I have to be nice, right? Nice is a Linux term, so you will be able to see it. Nice. If you are nice, then your priority will become higher or lower. Think about it. Think about the real situation. If you are nice, for example, on the crossroad, the streets, somebody comes in and you're so crowded. If you're so nice, what is your priority will become higher or your priority will become lower and lower?
You get to right away.
No, if suppose you are so nice, right? You want to let other people go, right? So you leave higher priority to somebody else, and your priority is lower and lower, right? So level of niceness is tells you the level of the low degrees, degree in low. It's not. Priority number is this. Negative number is highest priority because that is urgent, right? If your priority is, for example, 20, then there's a lowest priority, by the way. If you have a lowest priority, then all other process tell you that you are the nicest. Okay. Well, anyway, that is a different things.
Nice guys finish last.
Nice guy finishing last, right? Aggressive guys will get the higher priority and will get done quick, and therefore will be terminated quicker. Life will be shorter. If you are nice, then your lifetime on the computer will be longer. So be nice. If you want to live longer, be nice. If you do not want to live long, then you need to be aggressive and less nice and get higher priority. So when car runs into the destination group, then you have a highest priority. You need to jump into that car, and then you make your life shorter. Higher priority is shorter and less nice. Okay. But anyway, so that is a process. So while your process is running, not because of the interruption, but because your program needs to talk to external. For example, I/O, input and output. If your program is waiting for other data from external resources, then that is another stage, right? It's a waiting stage. And if you have the proper data, then you need to go back to ready states, and according to the priority, you can run or still wait. That type of things is a process. Okay, so let me bring this back up here. So what I want to do here, I want to make a sleep program running. I want to make it a little longer, 200, so it will last longer. So I want to get that sleep. Then I have here sleep 200. That is this PID. Probably that is PID. I want to see. Make sure if it is PID or, yeah, this is a PID. The other PID, I do not know what is. So this is a PID. So if you want to remember that this is now running, right? This is running. If it is running, then you can see the process ID. Type of interruption. So I want to kill it. One of the kill is another program, another command. Well, there's a program that created by someone else, right? And I'm now using it. And then there is another option called the 9, then enforce to kill. So which number? So 61, 26. So I want to kill it. So it says killed. I am killed. And stopped, right?
What's the difference between kill and p-kill?
Oh yeah. P-kill is you said I think usually we put the p-kill, so man p-kill. I believe when you say p-kill, then rather than process ID, we name it. Let me check. Manual p-kill. P-kill pattern. So we need to put that pattern. Okay. So let me do it again. Sleep. And then I want to get, in order to kill this by the kill command, then I need to have a PID, right? Process ID. But p-kill, I believe the name. So sleep and 200. P-kill help more information. I have the example later, okay? So please wait. That's a good question. Okay. What is it? I think maybe there is an option. If I remember, F for file. No. Let's see the option. pkill minus F is full. pkill HO pkill. Yeah, maybe sleep. Yeah, sleep terminates. Yeah. So different. When I say killed, then it said I am killed. When I say p killed, then it says I am terminated. They are the same but different the messages. So without knowing this process ID, if you want to terminate a process, then you need to use pkill. You don't need to do whole command sleep. I'm not sure if there is a 2 sleeps, what happens? That's a good question, right?
Yeah.
So
I think peak help you sometimes.
another here, 250. So 2 sleeps. And when I do PS, then I have 3 of those, right? So this is 200 and 250. So when I use pkill and then sleep, see which one's killed. Or none. Or both. Both. This is a machine gun. pkill is a machine gun. 2 at a time. There are so many people slips, then everything at once. Yeah, this is a good try, yeah. If I have more question, then we may learn more, right? If I don't get that question, then I don't get any. All right, this is a process. Program. Program is the file. So you can see the process list by using ps command. How can you get the list of programs? You already know ls, right? ls is the command that we already know. This is a command so that we can see it. And then finally, jobs. Job is a shell concept, which means sleep is, previously I have another terminal. Let me bring another terminal so that I have sleep 250. Okay. Here sleep 200. What is a program? Program is sleep. Sleep is a program, right? Program called sleep. What is a process? Sleep is a process, right? These are the process. Jobs and process, they are very similar term. Sometimes we call that job, sometimes we call that process. But strictly speaking, process is the shell concept. The job. Job is a shell concept. If the same program runs on this terminal, the same program runs on another terminal, then we have 2 different jobs running, right? So that's what it is. Of course, and therefore it has different process ID also, because this is 2 different the running. It's not the one running. So job you can get from like let me get this is running 250, right? So I want to put this into, this is up and running right now, right? This is a front job. Can I push it back to background job? You can do that. What is a command? Command is Control Z. If you do Control G or Control Z, then it stops. And then sleep is sleep killed or not killed? It's not killed. It says stopped, right? It is, we push it back to the background. So if you want to see the jobs, then you can see the jobs still available because I push it back. So it is now the job command. Let me see. Here's an interruption. Is a Control C, then this one will be interrupted and then stopped, right? I did that. So if I do jobs, then there's no job. Control C, there is no job. Control Z, then still there is a job because still slip 250 is stopped. Control C, interrupted and it is terminated. Man jobs. Oh, there's no man job. Man job. No manual jobs. Okay. No manual. Because Steve is not available right now, right? Steve Jobs. But anyway, that's what it is, okay? So this is a background job. How can you bring it back to the foreground job? The command for that is FG. Okay, you can do FG if there is only one previous jobs, only one stopped, one jobs stopped only, then you can do FG. If there are so many, then according to this jobs, there is a number, right? Number one right now. So you can say percent and number one, then that will be bring it back. So that 250 is still running. Oh, I think this is gone already. But let's do quickly. 250, and then I stop it. No, Control Z, stop it, and then I make it. And if I do this, see what happens. This is still in process, right? This process is not killed yet. So when I bring that back up, one, probably that is still running. That is still running, right? Because it is while this is stopped, it stops and waits. It's not wait. It stops. It runs a background job. Okay, Control Z means push it back to background job. Does it stop? No, it is. I mean, yeah, it stops. But does it terminate? No, it is not terminated. It runs at background job. Okay. So if you want to, there's I ask a question here. Send the job back to the background. Then the command is BG, right? BG. But if you have here, there's no prompt, right? There's no prompt statements. So you cannot do any command of this. Rather, you need to put shortcut keys. What is the shortcut keys? There's a Control Z. Control plus Z, then it will push it back to. That's what we looked at here. This is Control G, right? Control G. Jobs are tracked per shell sessions. So you may be able to see, yeah, there's some numbers there. If we have, is it still running? Control C. So let me, I want to make this and Control Z stopped, and I want to make another 300 and Control Z, push it back again. Then when I do jobs, then I have two jobs, right? The first one stopped slip 250 and second one 300. So I have here a number. So if we want to bring that the foreground, then foreground, which one that you want to bring it back to your foreground job. Yeah, then you can put the number. So first one come back, then you can 250 comes back. All right? There's a process. So we've done everything that we planned. Did we? We have more interesting things available. So one of the programs that can be running on your operating systems as a process, I brought up some interesting things, so I want to share with you. Okay, so long time ago when I was a student, we have there's a Stone Age, right? In that case, we have a fortune, like a fortune cookie in Chinese restaurants. Fortune, then I put that fortune. If you do not have a fortune, then you need to install it. How can you install it? Sudo apt install fortune and -y. Do it if you have. I think Zuli you are the only one now following me. Nobody's brought. Oh yeah, yours is your Mac. Yeah, yours is a Mac. Okay, Mac sometimes is okay with the command. Okay, so you can install it so that you can get fortune. Then you can do fortune. Then you can see here. You learn to write as if to someone else because next year you will be someone else. This is a kind of fortune, right? So fortune cookie, if I open it, there is a fly on your nose. So, yeah. Yeah, there's, yeah, all the funny or good phrases comes up. So it's not really bad. You can make it with a cowboy, here cowboy, if you want to install. So install it, and then fortune pipe cowboy. If you do here cowboy, cowsay, not cowboy, cowsay and ABC, then you can see here cow ABC. This cow say something. That is ABC. So what can we ask cow to speak? I want to ask whatever fortune tells to be asked to cowboy to speak. So I can do fortune and pipeline and cow say. Then cow may be able to say whatever fortune that I have. Oh, this is a long fortune. I'll make another one here. Cow say, yeah. You have to first install cow say.
Okay.
Those are the process, right? So this is fortune is a process, cowboy is a process, but this guy runs quick. So when I see them, it's already gone. But anyway, that is a process. So I want you to enjoy that. And the next slide gives you more. I want you to install left out loud. Install left out loud. So sudo apt lolcat -y.
What's the -y flag?
-y. Otherwise, there is interactively. So it says you wanna install it? Yes, no.
Okay.
So you can say yes upfront.
Okay, good.
So left out loud cat can take, for example, hello. Left out loud cat hello, no such file, or there's no file. So something we need to do instead. No. So we can say echo hello Morsi 221 class, and then pipe left out loud cat. Then it says a little bit different colors, right? So at each time I have different colorful echo. Not echo. This not comes from echo. This is from there. So left out. So we can combine fortune and Kausei, and then left out loud cat to pipe together. Then it gives you left out loud cat. Little colorful, right? So each time I have a different color. And different fortune. And another thing is Figlit. You can do sudo apt install Figlit and -y. Let's try Figlit. And then Mercy IASP 221 class. Boom. That's too long, right? So let's say Mercy. Boom. So we can also make another pipe, fortune. Fortune, Figlit. That's too. If it is short, then we can. Fortune is usually longer, right? So we don't see much. Another one, let's see. C matrix, sudo apt C matrix installed. So C matrix, character matrix. Keep going, right? So you can say, oh, you can demonstrate. My terminal has a virus.
That's from the movie.
Control C, interrupt it. So that is a process, you can interrupt it. Let's see, what is it? Install SL. So let's install sudo apt SL. So let's do SL. That's a good idea, right? Fortune and SL. Nothing happens. Okay, only train. Man SL. Is that manual? Probably not. Oh, there's SL. Display animation aimed to correct users to. So there is another options. A means an accident seems to happen to you. A for accident. L show little ones. F it flies. E allow interrupt by Control C. So SL minus A. Okay. Okay, the interesting thing that you may like is NeoFetch and EOFetch. NeoFetch and then NeoFetch. Then it fetches something from your operating systems. I am Jae-yoon at Raspberry Pi. Operating system is Debian. And host is Raspberry Pi OS 5, Model B, level Division 1. Kernel, this is kernel number. Uptime, so far 1 hour and 12 minutes. Packages, shell, so bash, 5.2.15 bash is running. Very interesting things, right? So everything about your programs. So memory is 600 megabytes. That CPU, I have 4 CPUs in this frequencies, 2.4 gigahertz frequencies. Terminal fonts, monospace 14. This guy really tells me everything about, not everything, something useful about my program, right? So we call that Neo Fetch. There's another similar thing is screen fetch. Screen fetch. But NeoFetch is better, right? Is there any? This guy gives me that disk space is given by this. Right now I'm using 7% only. I think NeoFetch. Let me see. NeoFetch gives me the disk spaces. NeoFetch doesn't give me disk space, right? Yeah. Something that we can get from screen fetch, in addition to what we get from NeoFetch, is the storage space. So I'm using 7%. So I wanted to play with that. I'll give you maybe 1 minute to enjoy it. So which one do you like the most? If we want to put them on your startup
The cow.
screen, cow. Yeah. To me, I think NeoFetch, so that I can, when I put up my system, I may be able to see who I am and some of the system information. Okay, so investigating some of the processes or knowing about processes running on your operating systems. There are also various commands available. So we'll look at that. We already know PS, right? And then BG and FG and kill also. Kill all. These two things are some of the good program that you can see and monitoring it. So let's try to do that. So if you see here top, then you can see all the process running. Not all. Top 10, maybe top, how many? 2, 4, 6, 8, maybe top 12 processes. So it gives me, there are 2 users because I have 2 terminals. Load average of that, task, 1 running, 222 sleeping, 1 stops. These are all the process procedures, right? Number of percent CPU, 4.6% only, right? And the memory size and swaps. And there is a little more better ones is htop. There's a command htop. Htop, there's a more user interactive. Okay, so you can see there's some command, F1, F2, you can search. And you can make it tree structure, F5. Let me see if my F5 runs. Or maybe click this, filter. I think I did done. This is filter tree. I have somewhere here tree, right? On the right and also I have here nice. Remember that nice? If I click nice, then I can see this stops. Quit. Let's see more. Nice. This is the level of nice here, NI. But it's not really. Oh, if I want to, for example, this nice plus and nice minus. If I want to make it nice minus, it's not really running. Probably, yeah. But that's what htop provides you. This is a top. Top simply is not user interactive, but it shows some the useful information by itself, right? So what top and htop can do? You can monitor the processes, right? So top display and update the task. Good to monitor processes on active, running, sleeping, stops, zombie, those things. And htop, nice interactive monitor if it is installed well, but my case it's not really. Some interactively, but some not necessarily. Okay. So the next slide shows you the screenshots that you can see similarly. Okay. And then there is a more commands for processes. So pgrep PID of pkill. This is something that we looked at, right? And the PS trees, nice. Nice, we can assign nice to some levels. So if you increase nice, then your priority will be going down. Okay, so we'll look at some of those. For example, PS3, it may work in this way. So I want to let it go and then stop this. F10 stopped. PS3, the processor currently running can be depicted in a tree structure. So if you scroll this up, then system daemon is running on that daemon process. I have a modem manager. These are the processes. Apache 2 running, cron, and there is a login bash, and then terminal type. Python is available also. Okay, those are the PS3 command. So you can see PS3 manual, display tree of a process. So options A, C, uppercase C, there's a color. You can assign some color. Command line arguments. -A. See what happens. So I want to. For this top, because this is not user interactive, you need to kill it. You need to interrupt it. So Control C to stop it. And then PS3 -A, see how it works. It says if you have a -A, then you can see the command line arguments. That is not the same as, for example, here, right? This is more, for example, WPA supplicant. Then we have more WPA supplicant -u run WS supplicant group net. Yeah. THD. That here THD, there's no command, but we can see more information about that from that option -A. PID of, this is another good command that you can get. For example, find the pgrep, and they are very similar. Pgrep or PID of. If we want to see as, for example, secure shell demand. If you want to get secure shell demand, for example, hey, what is a PID for secure shell command? Secure shell demand. I want to do something on that. If I have a PID, then you need to get this command, right? PS-EF pipe grep SSHD. But there is a direct command called pgrep. Pgrep SSHD, then you can get that ID 927 directly. This guy gives you a lot more than that. But if you want to use process ID only for a specific program, SSHID is a program, right? Let's try. If you run Python 3, for example, that is running. So if I want to do PS -EF grep Python 3, then I can get Python 3 this is one and another one here. This is the self command. So I have two processes on the Python 3. Okay, but actually this Python 3 is somehow originally that comes in. This Python 3 is the command that I entered here, right? That I activated. If I want to see, hey, I want to grab Python 3 so that I want to kill that specific process that I have here. This is a Python 3, right? This one is not that. This is something the server, when it first started up, this Python 3 came up. Therefore, I have here Python 3. Python is running here. Python here, right? This Python. Even before I started this Python 3, it is started up and running, right? Like this. And this is the process that I created here, just right now. If I want to kill these specific ones, if I have something wrong on this, for example, this program is hung, so I don't get any prompt statements any further, so I want to kill it, then the better command is pgrep Python 3, so that you can get this, and therefore you can kill it, right? You can kill using kill command or pkill, and then the program name. This is a program name, right? Kill, that is a process ID. So enforce it, process ID 7454. Then it'll be killed. It's killed. PID of is another thing that you can get. Rather than pgrep, PID of, then you can get 866. Right now, 86. Yeah, this one. This one is only available right now, according to that Python 3. When I run this, and when I have this Python 3, probably I have two of those, right? Thing is this, difference between pgrep and PID of is, if you have a PID of, this guy bring this as a program. So this program, Python 3 program, appears twice here. Therefore, it gives me the PIDs of those two processes, which are from the same program. That's what it is, right? And if you do pgrep, then, hey, I want to see the currently actively running process, so that I have only that programs. So find the PID of by name or pattern. Pattern in this case, that is this program name. Okay. So there are many useful commands already developed so that you can use it while you are running the Linux operating systems. you may be able to see, hey, I want to kill this process because that process is somehow hung. It's not really running properly. So you want to, if you identify that process or if you identify that program, then you can kill it. The way that you can find the process ID, many ways. Well, one single command is pgrep or PID of. If we want the list of the process status, then command the PS. If you know specific the program name, then you can pipe it with the grep. So PS pipe grep and program name, then you can get the process ID as well. Any question? Comment? And finally here, ls of. So let's take a look at manual first. ls of is a list of open files. So from that program, if you want to see here, see open files or sockets used by a process. See open file. Python 3 needs to run some other programs, some other files, then we may be able to see it, right? And then socket is what? If your program wants to run from outside, then you may be able to see that also. So let's try to do that. Right now we have here cd sp26. I want to make directory. Let's see how I make directory. Okay, mkdir 6 April 26. I want a 6 April only. So cd 6 April 26. Doesn't know nothing. I want to make a one program. Python. Samp input py. I want to make a simple Python program using Nano so that I can put here name equals input, and then we can say enter your name. And then I want to print entered is name. All right, so simple. And then I can write it out. So Control O, that is the file name that I want. Hit enter. And then I want to exit. Control X. So ls, then I have the samp imp py. You want to see, that is that program. If we want to run it, Python 3, and then samp int file. Then it says enter your name, right? So ps-ef grep Python 3, because somebody is running this, right? So as a system administrator, so you want to say, oh, is there anybody currently running Python 3? Oh, yeah, I have, 3 items, right? So in this case, you can see quickly, oh, that is, because this is a command that is, and that guy entered, right? But you can see that from ls of, and then let's see, manual again, man ls of, then we need to put name, open files, okay. So ls of Python 3, status error, Python 3, no such files. ls man ls of list open file. The location, maybe that is not this. Oh, because Python 3 is not there, right? ls of usr bin Python 3. Oh, okay. Command Python 3 PID user that device size of made of. Okay. So this guy, this is a command, right? Python 3 is a command. This command, actually, the file running for this Python 3 is coming from here, usr bin Python 3.11. Although I put Python 3, actual, which file is opened, as you see here, actually this file is opened. So Python 3 case is simple, but if on your system somebody installed some other unknown program and running, but if you want to see it, if you want to investigate what actual program is activated by some suspicious guy, then you may be able to get it from that command, ls of. Okay, so that guy is simply, this is a command, but actual program is from there. Process monitoring, what it does is to watch what process is running, how they behave over time. So you can see CPU use, memory use, state, whether it is running, sleeping, or zombie, the ownership of that program, sometimes I/O, run-away programs, and suspicious activities. So monitoring programs. So why you need to monitor? We already know, right? Secure awareness and performance management. This is something that you need to do for as the cyber security professionals. For system administrator, simple administrators points, then performance management, that is also important, right? But usually, if you do system management and also cybersecurity professionalism, then you need to use both of those. Of course, the system stabilities and the debugging and developments. DevSec development and cybersecurity guys needs to do this also. Debugging and developments. I'm waiting for that noisy stops. By the way, next week I'm thinking of having this class online. Winzen, so you don't need to come early next week. Winzen usually come here, I think, first. You're coming far away, right? Right. It's not near here. So next week I'll let you sleep more. You don't need to come. But I will come here. Why? Because even if I said, oh, next week you don't need to come online. If I am here, I see somebody's usually. So how come you come here? Class. Did I tell you that it's online this week? That guy said, oh, I didn't check. Come on in and take a look. You want to see my lecture? That guy said, no. I'm going back home to do on my own. So next week, the topic for next week is, no, we are not done yet. Abdul?
Oh, no, I'm searching my notes.
Okay. So next week, the topic is very, very useful and interesting things. I want you to set up web server, okay, on your Raspberry Pi. Like that is the typical. So what we want to do is we want to install Apache 2. We want to install PHP. We want to install MySQL database. So some data that can be stored on your. You guys didn't take yet database courses, right?
Taking it now.
So I'm not going further, but only Linux system administrators point of view. So we set up a packages. So topic for next class is packages. So how packages can be installed properly and configured so that your web server may run. You can access it from your laptop. How nice it is. So you have your web server running on your Raspberry Pi. You can access it from your laptop. There's another way that you can see the VNC. VNC is one channel. So you have another channel is HTTP channels. Okay. That's for next week. Why I am saying this? I want to see if you guys really, I mean, those who do not come here. Next week I'm able to see, oh, these guys really follow my lecture. If somebody come here, then the guy skip, right? So that my special announcement is not really effective in that case. All right, so let's move. Process. We already looked at this, top and H-top, right? PS, yeah, we do a lot. PS and PSAUX. PSAUX, let's try to see here. PSEF, that's what we looked at. And the other, oh, I'm not kill this. Okay. PS and AUX, according to the manual, PSAUX is a Berkeley version. There's no minus sign. Okay, this is PSAUX. So what is the difference? Okay, this is a Berkeley AUX. This is simply Linux command. UID, user, that's okay. PID, process ID, okay. And the next one is PS minus EF gives me C, S time, TTY, time, and command. PS AUX gives me more, right? Percent of CPU run by this program, this particular program. So we see the program here, and time when it was started, 8 o'clock or 9. Oh, right. The list ones. When was this started? 9:59. Right now, 10:01.
What's that like stand and idle? 'Cause I see a bunch of I and S.
Let's see what it is. This is stats. I think that is inactive. This is S. Okay. So let's take a look at that, what it is. Well, anyway, right now you see the difference, right? This gives me a lot more than that. So let's see S and I. What are the options that we have? SOI, right? And that is minus. So in order to get that, now we have, I want to get which one that I want to, Claude or Gemini?
Claude.
Or ChatGPT, Claude. Okay, so let's see. This is a process status, right? So R for running, S for, oh, this is sleeping. I for idling. What are the difference? Sleeping or idling? Sleeping is idle kernel thread. Sleeping for a long time. So idling is longer than sleeping time. Sleeping is a little bit shorter, right? I think this is the other way, right? Sleep is sleep. Idle, I don't sleep, but not working. That's idle, right? Idle.
You're waiting.
But see here, zombie finished, but parent doesn't collect its exit states. Dead. So those are the process lifetimes. It gives us process lifetimes. Right now we don't have any other idle or sleeps. That is small s, big S. Or here, small s, session leader. Small l, threaded process. Less than sign, higher priority. Higher priority, nice, yeah, nice is negative. And low priority, nice value is positive. I am nice, right? That's what it is. So Cloud is really helpful. Okay. So we now know PS AUX and PS minus EF. Right? We compare these two. Top and H top. Top is a classical monitoring systems. H top. Similar to H top, there's H top, A top, Galansys, P top, PP, Y top, Go top. So I want you to try for this, okay? Just rather than teaching, I'll let you do that because you can do it, right? Okay, let me do also A top. Oh, A top is not coming. So you can install it if it is not. Not installed. So I want to install sudo apt install. Let's try ATOP. Oh, ATOP takes longer.
Show network too.
Or let's ask to Cloud rather than boom. That's really good. So all of those are written in C except Python, the Galansys and GoTop. GoTop written in Go. Oh, this is more graphic. GoTop, maybe it's a little bit fancier. I want to install GoTop. PTAP is fancier?
Yeah.
PTAP Visual. Oh, I see. Okay, let's try to. So there's a future comparison So which one's the most?
Beta.
Glances gives most of those are the green lights. Limited means I think they may want to charge some. So you said the beta. Where's the beta? Beta is pretty good too.
Yeah, beta.
There are green lights. Yeah. Each tool in depth, HTOP, the way that you can install it. So let's see. I want to do beta. Oh, beta installation fast. Nice. Beta.
I didn't do that.
Too small. How come this guy knows it? Height also? All right. I like this. So on your system, if you want to leave for your lunch, then you can turn this on and show to someone who may not know about the Linux that you are still working. And they think, oh, this guy running some complex programs. He's working so hard. Yeah. Or this somebody really do not know may think, oh, this is playing game. Nice. Right? Okay. So we looked at that already, foreground and background. All right. Okay, kill. Is a kill command to stop the program directly, or kill is something else? Don't be confused. Kill is not doing something, some actions, but it's simply signal, simply send the signals to a process. Okay? Name kill implies, oh, that takes real action. But reality is not that. Kill simply send the signal to a process ID. Okay? So what is the kill command? Kill command, send signals to a process ID. Don't forget that. This is very, very important. It's not really taking an action. Take really strong actions. No, it is not. It says till does not directly destroy a process, but it sends a signal. The procedure is like this. While process is running, if I issue kill 9 and process, then there is a signal. Signal is sent by kernel. Kernel means this operating system kernel to PID. So this is signal is sending. Then scheduler removes the process from running. So who really kills? The operating system is kills, not the kill command itself. Scheduled is scheduled, and then process becomes zombie briefly. So when you issue the command kill, sending signal to the PID, so kernel knows that, and then schedule it and put it into zombie. briefly, and then kernel claims kernel knows that. Okay. Environment that we already looked at. If we want to see echo dollar variable, then that variable, whatever contained in that variable will be echoed, right? So, for example, I want to do, how can you stop this?
Q.
Oh, here, kill. What happened? Kill. Send the signal. Send this guy we already looked at, right? Kill means to send the signal. Seek kill. Remember that seek kills? To this process. Seek kill. Yes. Insufficient permission to send the signal. Oh my god.
Q.
Q?
Yes, Q.
Q. Thank you. Q. 그 Q shortcut key stronger than mouse click. Yeah, that makes sense. Mouse click may not be strong enough. Okay, so if I want to do print environment, then I can see all kinds of variables. For example, these are the color. So shell is that. So if I want to see what is your shell, then you can see echo and $sign shell. Then I can see, oh, that is my shell is bash shell. Echo $PS1. What is my prompt statements? My prompt statements that we can see is this, right? These are prompt statements. This guy tells me some of the color. So I have some green color. And then dollar Debian. Oh, no, here. This is color. This is user. \h user. @. So this is \user. @. And then \h. The host. And then colon. I have colon here. And then this is a current working directory. It's myself. WNA up to this, and then slash close bracket, and this is open close bracket. Everything that can be done here, and after that $sign. And after that, that is something about the coloring issues. That's what is this SP1. So written that way. See if we have SP1 here. So not really see here SP1, right? Yeah. Another one that I can show to you, because that comes in the next slide, SHLBL. So that is echo dollar SHLBL. What that means is that SH means shell, LBL means level, shell level. So shell level is number one. It starts from the number ones. You will see why that is important. I mean, sometimes needed. So you can create a shell environment, environment variables. The way that you can environment variables is simply, for example, me and hello. Then what is me? Echo dollar me, then that is hello, right? So defining a variable is simply the variable name equals and then the value. But there is no space. That is very, very important. It's not really typical programming languages, okay? Some other programmings, if you attach everything here, then it may be confused, right? But in this Linux, a little bit, this is a very, very old language, but somehow a little bit intelligent. So equal sign is, by having this equal sign operator, quickly understands one before, that is a variable, one after, that is a value. We don't need to say, for example, me equal this. This is not going to work in Linux. If you say this, the Linux doesn't like you, right? It likes you if you stick them together. Then it does. So me is a hello, you is a hello. If you want to put this in this print environment, then you need to export it like this. Export command. Then it goes into that print environment. Okay. Huh? No, only on this shell environment. If you want to do it, then you need to make a file, and when this program starts up, that file is now make a environment. So environment is not static, it's not fixed, it's not always available, but it is available after your system is boot up. So at the time putting up, bring that file up, therefore that environment variables effective.
You got to stick to a program pretty much.
Shell. Yeah. Setting environment. So one of those is here. Those are the files. For example, when you come back here, ls-a, then you can see some of the hidden files, right? Some of the hidden files already, like here, myself, .bash history, .bash underscore logout, .bash rc. RC stands for, I think, is a run. Let's see, what is this? I put that here somewhere. RC. Yeah, but RC stands for, I put that, yeah, run command. RC stands for run command. So if you see here, cat dot bash rc, those are the uh, this run commands is started when your system runs. Okay, we'll come back this a little later. So back here, so profile. This is the system profiles already defined. When your user is created, then this profile is copied into your home directory. This is so you have a user specific bash login configurations. This underscore profile login. So fall back if that bash profile does not exist, but if it exists, then it runs. So in my case, ls minus la. Let's see, ls. I'm not sure if it works. No, it's not gonna work. Okay, so bash, yeah, in my case, bash underscore profile is not exist. Bash underscore logout, this is only available. And then bash dot profile. Do I have a dash dot profile? Yeah, I have here dot profiles. So dot profile, that is to start up. Start up with this. It's generic POSIX shell startup files used if neither .bash profile nor profile login exists, then this profile runs. So let's see here, cat dot profile. This is, look at here, then if you look at here, this is dot profile, then inside it says dot bash rc is running, right? This is some command. So this is a shell script programming. I mean scripting, shell scripting, the Linux shell scripting. We don't look at this in detail today. Okay, scripting, the language needs to be understood first, but I'm going to tell you under some conditions, then actually this will run. Dot bash rc run. That is here. This will run. Okay. So that profile tells me which one that we want to run. Then this is running. So on here, some of the languages, right? Yeah, this guy tells me the print statements and the prompt statements that we looked at, right? This is defined. If a color prompt is yes, then we run this, otherwise simple versions. But the monitor is colorful, so that runs this. So I wanted to recall this PS1 variable returns that. Terminal information follows. and some of the alias. Okay. So those are the system variables are defined, and when the program first up and run, so all of this may be properly configured. Therefore, you can run your operating systems efficiently. That's what it is. When it logged out, there's one thing that I can explain about the shell scripting here. This is a remember this that I said that this is a system variable $shell level. If shell level is 1, when you log out, this takes place when you log out. Then first thing it check if that is a top level. If it is a top level, then also see if it has a clear console. This program is executable. This is the double and ampersand tells me if the first one is true, then we do the next one, right? This is a sequence of commands, right? We can make this a sequence of commands with two ampersand or two pipe. It tells you the difference, right? And if this is true, then we execute /usr/bin clear console. This is a specific program. This program runs. -q means very similar to -y. -y means, remember that when we install -y, then rather than I need to interactively enter yes or no, I give yes all the time. -q means it have some verbose returns. So instead of doing that, I can say that, hey, do it silently. Okay, quietly. Q means quiet. So it runs silently. It doesn't give me any messages at all. Okay, so when we log out, clean the screen. That's what it does. Okay, but this is the shell scripting language. I explained some of those here. Shell level ones. So what is the current shell level? Echo shell LPL. Shell level is 1. So when I do bash, then it runs another shell, right? So what is my shell level right now? Shell level is 2. When I do bash, and what is my shell level? Three. What does that mean? First, when I log in, there is a shell level 1. Okay, I have one shell. When I run bash is another shell, right? Bash is a shell. So I run shell, therefore I create a shell within a shell. So what is my current shell? Shell level is 2. So in the second level shell, I started another shell. So current level of shell is 3. That's what happens. So when I do exit, then it goes out. So what is my current shell? 2. I want to exit. What is my current shell? 1. When I do exit, what happens? then it log out. So it clean. Right?
Is that the proper way to like close the terminal?
Yeah, that's what it is. Clear the console. Here, so I have a logout. That's what happens here. When I do this shell level, when it was 2 or 3 or 4, even if I do exit, it doesn't clear. The console was not cleared out, right? Only at the time of shell level 1, when I do exit, clean that screen. That's why that happens, because I already set up this way. That's what it is. So it is not really something is going accidentally, but as it was designed. Who designed it? Oh my God, that is something brilliant, guys, right? They made this already. So we want to learn something from them. Okay, startup similarly. So let's look at more. Here, nice. Okay. So I want to get another one here. Let's take a look. PS minus EO. So PS minus EO, PID, and nice, and COMM. Unsupported option. Oh, option is not supported. Okay, then it's simply PSE. Okay. I want to make here slip 1000. So it may stay longer. So let's do H top. Do I have a slip here? This is only top 10. So what I will do, okay. All right. So I want to bring another terminal here. And then nice, the level of nice. What is a nice right now? What is a slip nice? Is it nice? Nice gives me here. Oh, nice is not given. Yeah, let's see. P-top. H-top. Okay, so H-top. Let's see H-top. H-top has here nice. Right now, my slip, the level of nice for slip, I do not know what number. So I want to make a nice, level, high level of nice up here. So number 1. So I want to make a nice minus n, let's say number 10 to sleep. Sleep is missing operand. Sleep. What did I, 1000? Okay. So I don't get any sleep here. This doesn't show much. Oh, that's what I had at H top. What is top? Oh, top also gives me. Oh, this is nice. Okay. So I have this guy somehow. Nice. I want to give some demonstrations of how I can see that. Control C. We made a Python program, right? Okay, here. So let's do Python 3 sample that. And I want to, I don't give any. So the Python 3 is up and running right now. I didn't answer any. It's still running. I want to see if it is available here. Okay, rather than having this, I want to give some nice. The number is number 8. So value is 8. I want to see if it is 8. Okay, let's do the example here. I want to see this. This is better. Okay, rather than sleep, rather than program. Let's see. So there is another terminal. Yes is another man. Yes. Yes is the output string repeatedly until killed. That is yes. There is some interesting command called yes. Okay, so I want to do yes. I want to send it to null. What does this mean? Yes is the sum of the command. Let's see one more time. So the output a string repeatedly. So when you do a yes, that it returns y, right? I interrupt that. Instead of that, if I say yes, then it returns standard output, which is on my terminal. So instead of that, I redirect to the device null. Remember that it goes into, it disappears, right? And then ending the ampersand means I want to make this the backend process. Oh, by the way, I forgot to tell you, right? You can make this backend process. You can make this or make this and then control G to backend process. You can do that. and the foreground, then you can put it back, and then you can make a Control C. Or from the beginning, you can run that program as a background processor. Process. Then you need to make here ampersand. Then immediately goes to the back end process, and the process ID is this. So returning this, it gives me jobs returns, right? So having that, then I can see top. Then I have a nice something. And now in the second terminal, I want to stop this. In the second terminal, I want to say nice minus n 15. 15 means very nice, right? And then I say yes greater than DEV this. So that I have here 15 came up. This is yes. Nice level 15. Look at this nice level 15s. The first nice, I didn't put any, the first yes command, I didn't put any, I didn't adjust the level of nice. So by default, niceness is 0. And then from the second terminal here, I put nice level 15. So you see two commands here, yes, but two different niceness, one with 0, one with 15. Yeah, we don't see the difference much here because there are not many processes running. But if there are hundreds and hundreds of processes running, if you needs to manage manually their priority, then you can change their process by giving the niceness. So level of niceness, as I said here, negative 20 is highest priority. Positive 19, that is the lowest priority. Lowest priority means that is higher niceness. So you can assign nice any number in between negative 20 and 19. The higher niceness means low priority. Lower niceness is higher priority. Okay, so I made that comment here, so you won't get any issue. That is nice. Isn't it nice? Any question? Any comment? Okay, VM state, virtual memory states. It tells me something like this. Okay, it shows me process, memory, swap, I/O, system, CPU. In the process, if it is all, it means ready. B means sleep. Memory, swap the memory, free memory, buffered memory, cache memory, swap in and swap out, I/O, in and out also, system, and CPU. So if you want to see that, then that is VM. It gives you very nice here. VMstat. So what is, oh, this is nice. So memory statistics. VMstat reports information about processes, memory, paging, block I/O, traps, disk, and CPU activity. The first report produced gives average since the last reboot. So it gives me the statistics. Memory is enough, right? So free memories. We don't use much on my Raspberry Pi. VMstats. Okay. So we can, this is VMstats. MPstats. MPstats is per CPU usage statistics, IO stats, disk IO and CPU usages, SAR, historical system activities and reports. So all these are something that you want to see the statistics about your systems, you can get them, right? So for example, VMstat, MPstat, then you can see some of the statistics. Percent of nice, 0.24. So 0 is in the middle, but 0.24, then little nice, just a little nice. IOstat, input and output. Raspberry Pi, that is today's dates. Average CPU per user, 1% only. Nice, 0.26. And then idle. Most of the time is idle. Unfortunately, right? My Raspberry Pi is not for production. Device, MMC block 0. Actually, this is a, so you may be able to see later. For example, if you have a USB stick, memory sticks, then it'll be the different the device that you can see here. Right now, this is a device of our SD card device. And then, yeah, IO or SAR. Cannot open, no such firewall directory. Please check if data allocating is even. No such firewall directory. All of them, as well as the packages. So if, yeah, we may want to install this. Sysstat. So let's try to install sudo apt sysstat already installed, but SAR is not. SAR minus U 1 and 5 returns something. Okay. CPU trend. Okay. So if I send from 1 to 5, then SAR gives me, yeah, 5 times, and give me the averages. Five times of that, and then finally the average of those. So it'll be much nicer if you have, for example, 1 to 20, right? So more information. So see how it runs. It runs all CPUs, 4 of those, and percent of users, and then average is this. So SAR is more like dynamic computation of statistics. I think this is it, right? Yeah. This is it for today. So today is very interesting things that we learned, right? Everything about the processes, some of the things that you can get the adjust among the processes. So giving niceness, different to niceness, so that you can manage the priorities of the process. Priority. Very nice. Okay. Any question? All right. Question, Nick. Mm-hmm. Tuning, yeah, that's another things, yeah. In reality, yeah, you can do that. But this is for simple exercises about processes. Okay, good comments. All right, thank you. I will see you in 2 weeks in person here in class. Next week, you can check out and watch the videos, and you will receive the homework assignments. There's no homework assignments from today's lecture, but next week, you guys need to set up a web server on your Raspberry Pi, and you need to give me some of the evidence. All right. See you.